Do that, we'll talk a little bit about terminology. Nothing too crazy. So stuff you probably already knew for the most part. Just a matter of really just kind of formally addressing these things. It's weird. My display doesn't like mirror perfectly that, so it's kind of annoying. All right. Well, statistics is a mathematical branch that deals with planning experiments, obtaining data, organizing data, summarizing, analyzing, interpreting, and drawing conclusions based on data. Quick question. Have I talked about typo bonus in this class?
No.
Bonus for typos? No? Okay. So let me do that now because I'm going to forget. And, oh, Ken puzzles. That's what it is. I have to talk to you about Ken puzzles. I'll do that tomorrow also. All right? But that's so important because on every unit test, for a bonus problem, I always throw in a Ken puzzle. It's kind of like Sudoku. And that's your bonus problem, all right? So it's just kind of like math reasoning, just number sense, things like that. It's very doable, has nothing to do with AP stats, just has to do with your ability to work with numbers, adding, subtracting, multiplying, and dividing, and that's it. All right, so how hard could it be? Incredibly hard. So anyway, no, I'll start you off easy. I'll give you a nice easy puzzle to start the year, then we'll graduate in terms of difficulty. But typo bonus, the way it works is every marking period, the counter resets. So you have the ability to earn up to 3 bonus points on a test, right? So anything that goes in the test category. So if a project counts as a test, it could go on that too, all right? What you do is you identify a typo in my notes, on my website, anywhere that I made a mistake, basically. So you get to kind of pick on me a little bit. And send me the typo on remind. So page number, what the mistake is, and what the fix is, if it's not obvious what the fix is. I mean, if you're like, you spelled branch wrong, like you then don't have to spell it out that branch is spelled the way it's spelled, because you would have spelled the word branch in identifying branch as being the word that's spelled wrong. All right. So identify the page, packet also, that's kind of important. Packet, page, what the problem is, and if it's not obvious, what the fix is. Do that for 3 separate occasions, and I'll give you 3 bonus points, and that's every marking period. All right? It's first come, first serve, because one year, the first year I offered this up, it was like, I think I'm on like 15 years of doing this now, and my notes have gotten better and better over the years, so that's why I do it. But your incentive is to get bonus points. But the first year I did it, I didn't implement the first come, first serve part of it. And so at the end of every marking period, I would have an entire class submitting the same 3 typos. So I would only get 3 unique typos. What I want is 42 unique typos, because we have 14 in this class now. So that's what I'm looking for. So all of that being said,
They're all dead.
I disagree. They're doing pretty well in here. Oh, okay. But before you say it, all right. So that's one of the things I wanted to address. Since it's first come, first serve, if you identify a typo, send it on remind. Don't say it out loud in class, because by the time you finished saying what the typo is, somebody else has already sent it in. They've stolen your typo. All right? So what counts as a typo? The obvious thing would be anything that's a typo, but also I'll accept spacing issues. Like I've done this before where I'll give you like 1 line of space to do the work for a problem that takes like a page and a half worth of space. It's cool, like that area won't know what I'm talking about. And then I'll go the other way. Sometimes I'll give you like a page and a half of space for a yes/no question. Like, so any spacing considerations that need to be adjusted, that I'll take that. Anything that doesn't flow grammatically, like maybe it's grammatically correct, but if it were worded slightly differently, it would flow better, because I was told by my high school English teacher, 12th grade, that I would be working in a gas station for my career. All right. He was basing that on my knowledge of the English language. All right. Well, he didn't know that I was like certified as a genius in every other capacity, but like that didn't seem to matter to him. But yeah, I have pumped some gas in my life, but I'm proud to say that that is not my career. So yeah, so that, and also things that I point out in class. I like to do that from time to time because then the race is on and I get to see you all like kind of like the flurry habit. So that whole spiel was just for me to say that there's really no reason why I should have a W with a slash when it takes pretty much the same character space as writing out the word with would. So I will take that as a typo, first come, first serve, right? And so you might say something like rephrase definition for statistics on page 8, right? What some people will do is take a picture of the issue and then circle the error and then submit that, all right? So plenty of opportunities for you. Now, if you don't get it, if you don't get the typo right away, and the reason why I ask you to submit it on Remind is I'll give you the thumbs up as the reply if you got it. If you didn't, then you won't get any reply from me, all right? So you might not get any typos for the first few weeks, but then you'll get a bunch of your classmates out of the way because they'll already get their credit for their typos, and then you'll have fair opportunity to get some typos down the line. Absolutely, yeah. Yeah, I got one in the back too. I got a station back there. I got one up here, so yeah, that's for everyone. All right, so individuals. We call individuals the objects described by a set of data. All right. So the key is individuals are not necessarily going to be people. All right. That's something very, very important. If you fall into that trap, you're going to run into trouble. Individuals are just think of it as a singular. All right. So a singular element in a particular set. So that chair could be an individual. All right. So that's just something that's very important. A variable is any characteristic of an individual. A variable can take different values for different individuals. I think that part is obvious, but we think of variables as X and Y. Here in this class, we think of it as anything that varies. The problem is variables aren't always quantifiable. All right. Sometimes variables are categorical. Right. So gender, grade level, you might think that that's quantifiable, but what do the numbers actually mean? All right. So when I say that, you know, you're in 9th grade versus somebody's in 10th grade, 11th or 12th grade, you have the number 12 assigned to you versus somebody who has the number 9 assigned to them. What do those numbers mean? At this point, they're just labels, right? So, and now they do represent years. Now, if you're focusing on ages, then it could have meaning. But if you're just focusing on as an identifier of the characteristics of a particular subgroup, then it doesn't really have much meaning at all. So that brings us to categorical data. You're going to put data in one or more categories. All right. So that's the thing. We have statistical displays, and those statistical displays deal with the concept of putting data into either categories or evaluating them numerically. All right. So if we're looking at categorical data, you might be thinking of something like a box, sorry, not a box plot, a pie chart, or a, what is it called? A bar chart. Sorry, I'm just getting distracted by all the side conversations. So those would represent categorical data. Folks, I just gotta get your attention for a sec, because like you've been talking the entire class period so far, and when I'm doing the lecture part of class, that's where the focus needs to be. The side conversations can happen later on, all right? And there will be plenty of time for that. The idea is that I can get through the content without the distractions, and because what's going to happen, and I'll be straightforward and honest with you about it. This course goes from like, wow, this is no more than 7th grade math, to I don't understand why I just got a 50 on that unit test. All right. So if you miss the transition from where it's middle school math to where it becomes, whoa, what just happened, then it's it's a train that you'll never be able to catch up with. All right. So you got to be with me when I'm doing the lecture part of it. When I let you free, then that's fine. Then you can have your side conversations while you're working. That's totally fine, and I'll engage you in side conversations too. That'll be I enjoy that. If it's not something that you think you can control, if you don't think that responsibility is something that you have within you to maintain, then I would question whether this is the right environment for you. All right. So I'm just saying that. It's done, I move on, and now we talk about quantitative variables. All right, quantitative variables are numerical-based variables. Those variables are ones that you can assign a numerical value to, and that numerical value has meaning. All right, so a grade on a test. Can I assign a numerical value to that? Yes. Does that numerical value have meaning? Yes. Perfect. All right. Now, if I were to ask you your opinion on the most recent debate. I don't want to get too specific when it comes to that stuff, but the most recent debate, your opinion, and I give you maybe like 4 different choices. So I'm basically giving you your opinion. You have 4 different choices. Would those 4 choices be quantifiable? Maybe, maybe not, depends on what the choices are. But if it's something opinion-based, then probably not. It would be categorical. Like, I agree, somewhat strongly, disagree strongly, that kind of thing. You can rank them, the level of agreement from high to low, but you wouldn't be able to say that numerically that you could subtract 2 values and get a meaningful number.
If you have a scenario where a mode would be helpful, where you have numerical values, but you only have like a span of maybe like 5, and you have like a lot of the same, could you consider those categorical and use like a bar or a pie chart?
That's what I would do.
Okay.
Yeah, that would be the way to go. All right. So distribution of a variable tells us what values the variables take and how often it takes these values. So we generally know that kind of thing already. All right. So this little example here, small section of data describing education in the U.S. We have SAT scores, and then population in thousands. All right. So this is basically millions, because if you just slap on 3 zeros to each one of these numbers, that's what we're looking at. All right. So we would identify the individuals and the variables. All right. And then determine if each variable is categorical or quantitative. All right. So what are my individuals? See, when you're given the data like this, it's not always as cut and dried when you look at it. There's a lot of stuff going on in this table, even though it just seems like numbers everywhere. And in fact, you could probably interpret it in layman's terms, or lay people terms, I don't know what the right way of saying it is, without getting into statistical terminology. But if an individual is a singular of a collection of a set in an experiment or some kind of study, then what would an individual be in this context?
1,000 people within.
Yeah, you could look at it as a group of 1,000 people. Now, if you manipulate the table, and because it says population in thousands, if you were to slap those 3 zeros onto each one of those numbers, then you could make the case, or actually, it's more than make a case, you could just simply state that an individual would be a single person. All right, but because it's already grouped in the table, that's pretty much the way it is. All right, now so we know the individuals that the study is being conducted upon. Now, what would be, now, I put plural on just about everything because I don't want to sway you in any particular direction. So, individual, but on a test, I'm a little nicer. I put the parentheses around the S, indicating that it could be maybe just a single variable or multiple variables. In this case, there's only one variable. So, actually, you can make a case for two. I'll show you the other one, but one is obvious. So variables. Give me a variable. What's something the variable?
The SAT verbal score?
SAT scores, yeah. I'll be more general. I'll say the SAT type. All right, because SAT verbal versus SAT math. All right, studies have been conducted ad nauseum to determine if there's some kind of relationship between the student's performance on SAT verbal and SAT math. Generally, what they've shown is that there is no causal relationship, but there is a correlation. As one goes up, so does the other. But then they tie that all back to wealth, which is why they're revamping everything in College Board. What's that?
They always say that.
They always say that, but then what they're going to do is revamp it into something that is still going to be wealth-based anyway. So, honestly, I think about stuff like this, and I think about my summer vacation, and it's hard not to compare something like wealth to performance academically, because I think of it like if you're so poor that you can't even be in a classroom, then yeah, it's pretty obvious that there's a connection between your socioeconomic status and your performance academically, because there is no performance because there's no academics, right? So, when I'm touring through a country and I see people bathing in a river, like literally bathing in a river, it's like, yeah, they're probably not going to do so well in school because of the standard of living is just completely different. So, until they get that kind of stuff squared away worldwide, I don't see how there's any easy fix. It isn't just like, all right, we'll change the number of questions on the exam. That'll make everything all right. No, it's not going to change people's lives. So that's my soapboxing for today. Anyway, another variable loosely could be the population size. Because we have the three different groupings there, and depending on which group you're in, it might have an impact on things. It does seem that whoever was conducting this study was trying to make a case, just by reading the data, that if you have a smaller population, that you're going to have more consistent scores between math and verbal. Because you have the 4,600, 4.6 million, whatever, and then the 3,500. Those are more consistent with one another, whereas the 35,000 was a little bit more spread apart. All right, so whoever is presenting this data may be doing it for the purpose of getting people to think that increase the population and you're going to increase the disparity between math and verbal scores. And that's actually going to be the subject of your project that we're going to start tomorrow, where we're going to look for misleading representations of data. Right? It's going to be pretty cool, and I'm excited to see what you come up with. But I don't want to steal my own thunder, so more on that tomorrow. All right, so determine if each variable is categorical or quantitative. All right, well, I think population size, I think that's pretty straightforward, right? They're numbers. The other one would be categorical. All right, so population size, if I have 20 people in this class and somebody else has 10 people in their class, there's a size relationship that's quantifiable. I have twice as many as they do. But if I say somebody's taking the SAT verbal and they get a perfect score versus somebody who gets, let's say, a 700 on the math, the SAT math, it's apples and oranges. I don't know. Like they tout them as being like benchmark exams, but I don't know that a 700 on the math is even comparable to a 700 on a SAT verbal, let alone an 800. So it's apples and oranges. So there's no comparison. Therefore, categorical.
The reading one is designed to not be like able to get perfect score. People do it.
They used to have that, and this is the model that they wanted to do was a computer-based exam system. And they used to, for the graduate record exam, the GRE, they used to have a writing sample. And the way it worked is the way they wanted to make it work for the SATs. So it would be a content, it would be content-based, but also the length of the paper would be considered as part of the grade. So what they were recommending that people do would be answer the question, write a well-thought-out essay, and then just type stream of consciousness after that to add the word count. Because whatever software they were using to grade it was assessing whether or not you had the keywords in there, and then overall length, and then that was your grade. It was such a flawed system. But yeah, people always find a workaround. That's just how. Creating this pie chart by hand. And you would actually need a protractor to do it. You would determine all these percentages, all right, which is not the hard part because you just get your counts, you get your total, and then divide them, all right? So what you do is you then take the 0.27 and multiply that by 360 degrees. I thought the phone was buzzing, but it's not, so now I'm worried. It's like that phantom buzz in my leg. It's troublesome. 97.2 degrees. So that's what this angle would be. All right. So what you would do is draw a line segment and then measure off 97.2 degrees from that, and then do the same thing with 23 degrees. 23%, 22%, and so on. All right, so it's not difficult, it's just a little tedious because once you have the angles, then you draw a circle around it. All right, now the quality of the circle is where things, they don't need to be overly precise, but let me see if I got what it takes. Well, let me get the angles actually. I'll just do it on the sideboard. 0.23 times 360. So this is going to be 82.8. $79.2. $100.8. And this is where people have kind of gone sideways before. Very, very important. The center, shape, and spread and outliers of the data have to be addressed whenever you construct a statistical graph related to quantifiable data. Right? Categorical data is a different story because you're not talking about outliers, you're not talking about spread and things like that. You're really just talking about the mode more than anything else. So you can talk about center, I guess, but you're not really talking about anything else. But when you're dealing with quantifiable data, these four aspects need to be accounted for. And this is something that people have kind of lost sight of in the past. And so I'll say, and here's the thing, you may want to make a note of this to yourself, whether the question asks you or not, you have to account for these. All right, so if I say create a statistical graph and you just create the statistical graph, that's not full credit, right? You haven't answered the question, right? The statistical graph comes with the analysis related to center, shape, spread, and outliers, CSSO, all right? So it's a studying component. You got to make sure you do this. Now, as far as the dot plot is concerned, really all you're doing is you're taking your data set, very simple. You have a raw set of data. You're going to create a number line going from the lowest value to the highest value, and then you're just going to put a dot for every time each one of those values occur. Right? So when we're talking about runs scored by the American League in the last 21 All-Star games, so 21 games. So there should be 21 data points here. All this is telling me is that the American League scored no runs once, 2 runs 3 times, 3 runs twice, and so on. But I could also address some summary statistics here. I can get an average. I can get a sense of spread. I can get a sense of the distribution. It feels like it's shaping up to be somewhat normal, right? We don't have a large enough sample. 21 values is nowhere near, it's not nearly considered to be large. Generally, they say 30 or better, and then you could start getting into the conversation of assuming that a data set is approximately normal, but the larger the better. That's another wishy-washy aspect of statistics. If you were to ask me if you have enough data collected, I would say, well, how much do you have collected? You'd say 50 data points. And and then you say, is that enough? And I say, well, is it? And then you say, I don't know. And my response to that would be, can you collect more? If your answer is yes, then it's not enough. If the answer is no, then it's enough. All right? So, like, how does that work out mathematically? It's kind of strange. The more data you have, the stronger your conclusion is going to be. All right? So, if you have 50 data points, you're going to draw a conclusion. It's not going to be as strong as a conclusion drawn by somebody who has 100 data points. All right? So, it's always going to be comparative. All right? So, here, I'm looking at the bulk of the data somewhere in the middle, maybe around 4 or 5, maybe in that 4 to 7 category. The shape, you might make a case that it's somewhat skewed right? It seems to be tailing off to the right. Dispersion, the spread of the data, that's a little bit on the iffy side. All right. So if I were to tell you that the maximum difference on a set of test scores for all of the students taking calculus in this high school, the maximum difference was 13 points. All right, so we're just talking about the range. All right, the difference between the highest and lowest score was 13 points. Would you say that's a large number? No. All right. Now, if I tell you that, you got to have at least a little bit of a sense of sports in order to understand this. But if I tell you that the Yankees or the Mets, because I don't know who likes what, I like the Mets. I'm sure everybody likes the Yankees, but I have to involve everyone, I guess. You know what? Forget it. No, I'm not doing that. I refuse. If you're a Yankee fan, forget you. The Mets scored 13 runs last night. What are you gonna say? Surprise. You're gonna be surprised, all right? And actually, I'm just kind of painting myself in a corner here because I'm inadvertently going to be making fun of the Mets. So if the Yankees scored 13 runs last night, are you going to be as surprised? No. Okay. Yeah. And what was the score yesterday? What was the final? 12-11. 12-11? That was something. Because I looked at it, I was like, wait, what? The Mets, they won 2-1. That's all I care about. Just the W. Looks like this.
And they didn't blow it.
And they didn't blow it. But that's only because we had a 1-run lead and absolutely no inclination to bring in Edwin Diaz.
Well, that's smart.
Yeah, just like put him on a plane to Disney World or something. All right, outliers. Outliers is a different story. There's no way around it. Outliers have to be addressed mathematically. All right, so I was able to do some hand waving around the other things, but the outliers we got to tackle that using either the calculator or by evaluating the data by hand. Now with the dot plot, it's actually not terrible to do it by hand because you could just count dots, but maybe you don't want to do it because this dot plot is set up for a frequency table. So let's do that. All right, so stat edit. I'm only going to put the relevant x values in. So 0, 2 through 7, 9 and 13. And, what's that?
Make it a frequency table.
Making a frequency table. And I'm going to put the associated frequencies in there. So 1 0, 3 2s, 2 3s, 4 4s, 2 5s, 1 6, 4 7s, 2 9s, and 2 13s. So we could get our measures of spread and center, but again, I just wanted to review the concept of finding the outlier. So I'm going to do second y equals. I'm going to make sure the modified box plot is on. What's the adjustment I have to make in this window? Frequency's L2, all right? Now that alpha lock again is still on, so let's get rid of that. So second 2. Zoom 9. No outliers. All right, so you may have looked at it and said, it's surprising if a team scores 13 runs, but it's also more surprising for some teams than others, right? So if the Detroit Tigers scored 13 runs in the game, that's actually who the Yankees played yesterday, right?
Yeah.
And they actually scored 12, yeah. So, but they're like the legit worst team in the history of baseball. So, yeah. Anyway, my examples are not really, really not flying off the shelf today. But center, shape, spread, you can evaluate that using your direct observation in a lot of cases. The calculator will do the work for you in a lot of cases, but outliers, you need a mathematical approach. All right? So there are no outliers. And that's because we use a modified box plot. All right, so what I would like you to do is really just address, and this is the only thing I want you to do for homework, is address this one question. Describe the overall pattern of the distribution of runs scored by the American League. So I addressed each of those components individually, but what I'd like you to do is in a brief summary statement, just write up what you think is going on in that graph, or what you think that graph is telling us about the American League teams or American League players' performance in the All-Star game. All right? The good news is you don't need to know about baseball in order to answer it because it's just by the numbers. All right? And then we'll talk about our responses tomorrow. I'll ask a couple of you to read yours out. It'll be